Hello, hello, hello. My name is Soyasid Yang Sao. I am very delighted to present a load of delta connection. This is the load of delta connection, and it is a balanced load. That load is supplied by a source under a voltage VL. Considering, the current at this delta load. Firstly, you have the current of the three-phase ICA, IAB, and ICB. And let's consider only one current from the source, and that current is IA here. In terms of sign, you can express IAB as equal to the RMS value of IAB multiplied by the square root 2 multiplied by the sine omega t. Taking into consideration, the reference of 0 degree. ICA is equal to the RMS value of ICA multiplied by the square root 2 sine omega t plus 120 degrees. IA, the current from the source, is equal to IAB minus ICA. So IA is equal IAB plus minus ICA. To simplify the addition instead of subtraction graphically here. Now, let's represent these three currents graphically. Number one, you have the current in blue for IAB. The current in green for minus ICA, and the current that you get for IA is represented by the sine wave in red color. Now, some observations have to be made relative to these three signals. Number one, at 30 degrees, the value of IB is the same and equal to the current minus ICA, but they are of opposite direction. So the addition is 0, and this is where you start the current, the line IA, represent here by the red signals or the red waveform. At 120 degrees, you can observe that the current IA reach its maximum value, IA max, because it is the addition of the current IAB and minus ICA. So you have the double of this current here for IA max. At 210 degrees, the current IA becomes 0, because the addition of the minus ICA and the current IAB are equal, so they cancel by addition for 0 value of IA. Last observation, not last really, it is the IA minus the IA marks in negative value or the minus IA marks. Again, at 300 degrees, the addition of the current IAB and minus ICA give you this maximum negative for IA, and IA will be 0 again at 390 degrees. You can compare this solution by graphics to the phasors. Okay? Representation of the phasors is that you have this vector I, AB as reference, or the x-axis, followed by the current IBC, which is followed by the current ICA. Now, you take the opposite of ICA, that is this vector here. So, combining minus ICA with IAB, you get IA, which gives you 30 degrees here, and the phase current is leading the line current. It's as simple as that with phasor or with complex numbers. Any question? No question. So I thank you very much for your attention. I hope to see you again in another lesson of electrical circuits.